Hello everyone. In this video we are going to look at how we can answer questions when we are dealing with just general discrete random variables. So in this case, our discrete random variable, it is not following like a pattern like we know with binomial, but it has provided us everything that we need in order to establish the probability mass function and the cumulative distribution function. Okay, so let's go ahead and look at this right now. So it says that Pam is looking to invest some of her hard-earned money. She's found a classic investment that she knows is pretty safe, but her friend showed her a startup that possibly has a huge return. The following provides the probabilities of return for the respective investments. Help Pam determine where to put her money. Okay, so essentially we're basically going to be looking for how to calculate out the expected value of each of these different types of investment options. Okay, so let's look at the classic investment. We'll just label it classic. And we will label the other one as startup. Let's make this a little bit bigger. Great, classic, and we'll go down here to startup. All right, so the first thing that we want is our support. And then we want our PMF. And we want our CDF. And then we can answer a bunch of questions that we might have. So let's copy that and paste it. Okay, so the support for the first one, and we're going to put these in ascending order so they get bigger as they go down. So our first one, we have negative 3,000. That's like you lose your money, or you lose $3,000 of your investment. The next one is you make, or you gain $4,000. And the last one here is you gain $6,000. Okay, and then for the startup, it's possible that you lose $13,000, you lose $6,000, or you make $31,000. All right, so now we need to look at, okay, what's the probability of each of these things actually occurring? So the probability mass function here is we've got equals equals 3 divided by 10 for the first one, equals 1 divided by 2, and then equals 1 divided by 5. Okay, and then the startup is going to be equals 3 divided by 5, equals 1 divided by 3, and equals 1 divided by 15. All right, so remember the rules of our PMF is that the probability of each individual event occurring has to be positive. So first of all, do we have a positive probability? Yes, we got positive. It must be between 0 and 1 inclusive, so they have to actually be a probability. And if we were to sum them up, they need to equal to 1, so that every possible outcome has a probability, and they all sum up to 1. Okay, so let's do a quick summation of these guys. So you can either type it out sum, and then highlight the values, or if you don't like doing that, you can do equals first one plus the second one plus the third one. Either way to do this is just fine. Okay, and then the CDF. So remember, the CDF is the probability of an event and everything before it. Probability of an event and everything before it. So when we're doing with this general situation, we have to kind of actually just do the math by hand, and it's not too bad. So the first one is just going to be equal to 0.3. Great. Second one, equals the sum, or if you don't want to do the sum, we can just add them up, this guy plus this guy. And then the last one is just going to be equal to all of these guys, and they equal to 1. Same thing over here, equals 0.6. This guy equals the line that we're on and everything before it. And then this one, we add them all up. And they should equal 1. Okay, so we have we've built these tables to help us out answer some of these questions. Now, the next thing that we need, though, is we need to figure out what is the expected payout. Okay, so the expected payout is like if we were to invest in the classic option over and over and over and over again, on average, how much money would we walk away with? Now, sometimes you'd walk away with $6,000 on a single time. Sometimes you walk away with losing $3,000. But if you kept investing in it over and over and over again, how much do you walk away with? So when we're looking for this is like the expected value of x is kind of how we talk it out, or how we write it out, or the expected value of the random event of this classic event. So we need to do a little part here first. We need to do this intermediate calculation, x times, or the support times the probability of the event equaling the member of the support. So let's do just a little bit of calculation. So we can do equals 3,000, negative 3,000 times 0.3. And I could keep typing this down, equals 4,000 times its probability. Or instead, I can also click on the cell, and then in this bottom corner, notice how I go from this like white plus to a little black plus. And if I click and drag it, it propagates down the equation. Kind of a handy little tool, but if you don't need it, that's fine. Okay, so the expected value is actually just the sum of all of those values. So we can just do equals this little column that we just made up. And the expected value for the classic event is to get $2,300, or that if we were to play this over and over and over again, on average, we'll make $2,300. Okay, next question. What return are you most likely to see from the classic investment? Okay, so this one is just simply saying, okay, if we were to play this once, which of these options are you most likely to see? Are you most likely to walk away with $6,000? Are you most likely to lose $3,000? How do you figure that out? Well, it's actually very simple. You just go to the PMF and you see which PMF has the highest probability. And this support is 4,000. You are most likely to see $4,000 on your return. Now, sometimes it's negative 3,000. Sometimes you're going to get 6,000. But most likely, 50% of the time, you're going to see 4,000. Okay, next. What is the expected value of the startup investment? Okay, so we know exactly what we need to do again. For our startup, we have to do this little intermediate column calculation. Oops. And we can just do equals the support multiplied by its associated probability. I'm going to just drag that guy down. And the expected value of x equals, and this time I'm just going to type out sum. So I've gone back and forth with using sum or actually just putting in plus signs between everything. Either one is correct. And we get negative 7,700. So while it's possible that you can get on a single event a single big payout, the probability or the likelihood of what you're going to get is actually you're probably going to lose money, right? You are probably going to not make a lot of money. Okay, so let's go ahead and look at this. Negative, 73, or 7,733. Which investment option are you most likely to lose money? Or are you most likely to lose the money that is in the startup? All right. 2 more questions. Suppose we have invested in the startup scenario and your account manager just told you that you have lost money. What is the probability that you have only lost $6,000? Okay, so this is kind of like a given statement. So given that we have lost money, what's the probability that we've lost only $6,000? Okay, so if we want to look at this, what we need to do is, it's kind of this given statement. So let's do probability that we have lost, let's say, $6,000, given that we have lost money. Okay, so if we go back to our basic probability things, right, we know that this is the probability of negative 6,000 intersect lost divided by the probability of lost money. Okay, so let's look at the probability of negative 6,000 intersect with the lost. And that is just going to be right here. It's because losing money is these two together. Specifically, the negative 6,000 is going to be this 0.333. So we can say equals 0.333, or instead of typing it out like that, it's better to click on it. There we go. And now we can divide by the probability of losing money, which would be both 0.333 plus 0.6. We then enter, and there's like a 35% chance that we've lost $6,000. Okay, excellent. Next, suppose we have invested in the classic scenario. What's the probability of not losing money? Okay, so this one is just up here. If we go here, we'll type it as the probability of not losing money, or we could say making money. And that's just going to be equal to the probability of 4,000 or 6,000. And that's just going to be equal to the probability of 4,000 plus the probability of 6,000. And we hit enter, and it's 0.7. So that's kind of how we can go through, create these probability tables to help us answer some basic probability questions. Best of luck on applying these on your own general probability problems.